Hey guys, so I'm going to talk about basically do a quick demo of, loading a robot inside the PyBullet simulation environment. And I'll also talk about the URDF file, how to change the parameters, uh, how to, make a new URDF file that, has the robot that you want. And I have a video of introduction video about how to set up the URDF file and what is the different components of the URDF file is, like such as the links, joins, and how it's read by the Python script. So that was quick intro, and today I'm going to do a demo. So if you haven't seen that video, probably need to see that because it kind of gives you it's quite short, maybe like 10 15 minutes. Kind of prepares you for this, so it makes more sense to you as you watch it. So here's my Python script, right? So let me bring this here so you can actually see the code. You have you do have the imports, PyBullet time and PyBullet data. You're using line 4, you're connecting to the graphic user interface, which is what we want right now. We want to see the robot. Then we are connecting to the PyBullet data, which is actually where you can download like plain URDF or R2D2 URDF. It's where where the library of the PyBullet is. And if it's not connected, these things are not going to be loaded. Then start position, start orientation, which is 0, 0, 0, and we're loading the R2D2 with the given start position and orientation. And we're creating time steps at 1/240th of a second. And we're stepping through that for 10,000 times. So imagine it's going to be around, I don't know, maybe 2, 3, 4 seconds. I don't know. You can calculate it. But then we take the final orientation position and we're going to print it because we want to see where it's end up relative to the beginning. I'm going to run this, so it's going to load the R2D2 robot, and we'll see what it looks like. So it's loading. Let me bring it up so you can see it. So you can see this robot. This is not the R2D2 because it's not saved. I see. And now I saved it. Let me do it one more time. Now I have the R2D2. I need to change the window so you can also see it. So here's the R2D2 robot. I can zoom in with 2 fingers or zoom out. You can also grab the robot, throw it around. Right? So that is that. So it's off the picture. Now I'm going to show you something else. So it's quite straightforward. This is kind of a hello world of PyBullet. Now I'm going to show you another way of basically bringing in robot. Here's the robot that I, kind of created just by simple shapes inside the R2D2, inside the URDF file. So we have an XML version 1.0 with the quadruped robot material name. So we have a material name with the color that is defined with the RGBA. We name it blue, so you can name it anything. but we are giving it like RNG, red and green is 0, blue is 0.8, and A is 1. This is, a little more advanced than I wanted it to be. So forget about the material part right now. Focus on the link. So the link says you have a link with a visual and a collision and inertial. Also, this is a little extra, so I'm just going to remove it for right now. And the inertial. So as you can see, the link is, this is the end of the link. So you can comment this out just like any XML file. So this is not being commented out. Oh, you have to bring this inside. And then you do this. So you kind of comment the whole field out. So the link that I'm talking about is this one. So we have all these links, right? And joint, link, joint, link, joint. But when you start this, because you're going to run into errors, so I would recommend before you create your own advanced robot, you just load up one link. So I'm going to remove all of this here. Do a Control X and try to save this. And I want to make sure that this actually loads inside quadruped underscore robot, the URDF. So I'm going to stop this thread, load this one more time. So what you see here, after I show it to you, is that one link that I just created inside inside the URDF file. So let me go back here and show it to you. So that one link I created in this quadruped robot is this one right here. So we have a geometry that is a box with the size 0.6, 0.3, 0.1. So these are the 3 dimensions of the box. And the material, I mean, I wouldn't worry about the material for right now, but it's here. So don't pay attention to the material because that's kind of advanced for this session. And then you have the collision. Collision is the same exact thing as visual because we want to have the same shape as we see it. If we completely remove collision, what happens is that the robot is going to be loaded and goes through the plane because it doesn't have any surface for collision with the plane that URDF. So therefore, you see it here, and right now they could be different, but that's the way they interact with other surfaces. So the collision part is. So you could shape it differently than it looks like, but at the same time, for the most part, it's going to be the same as visual. So as you can see, we are seeing this piece of robot, the piece of link that's landing here. So the next thing I'm going to, so here I showed you the link. You probably didn't see it because it was covered by. So here's what I was talking about. You have visual and you have collision the same geometry. We have the box with the sizes 0.6, 0.3, and 0.1. That's the only thing I have in this entire file, and this material is kind of irrelevant right now. I could remove it if I wanted to. So the next thing I'm going to do is I'm going to add another link. This is the next step, okay? So I have one link and then two links. So so let me remove the rest of it for right now. Link, joint. Make sure you see it. So now I have another link. I added the second link. So that was the base link, and now I added head with the same box visual and a box geometry for the collision. Material name, which again is irrelevant. Inertial also irrelevant. I could remove it. That's something you learn as you go, but I would say do not pay attention to it for right now. We'll get to it later. So the important thing is that when you add the second link, you have to add the joint that's connects the two. And if you do not add the joint, it's going to give you throw an error that you don't have this. It doesn't tell you what exactly it is, but that it doesn't load the robot. So I'm going to right now stop the previous thread and again see what's happening. So I'm going to show you this robot that is supposed to be a base and a head. I don't see the head for some reason. Let me see if there's something wrong with this. If there is something wrong. Yes, something is wrong because I didn't save this file. I'm going to run it again. So you can kind of see the head right now. It's loaded with the robot. So zoom in, you can also see the head. Okay. But what's inside the joint? I didn't talk about that part. The joint has, a name, a type, which is right now it's head to the body, so we made it fixed. It could be a revolute joint or it could be continuous joint. A revolute is the one that kind of revolves around an axis. You also have a parent link and a child link. Both of them is required, and then you have the origin. Origin is where the child link connects to the parent link, and it gives you those coordinates. I think it's with respect to the parent link. Now I'm going to add the rest of the robot. So it is pretty much the same process. Once you add a link, you add a joint. After the first link, so the first link you do not need a joint. Starting from the second link, you start adding a joint for each link. Now, if I save this and run this one more time, you will see the completed robot, which is right here. 4 legs, 1 head, and 1 body. So what is the other legs? You have the front left joint. So these are revolute joints, okay? And then you have the parent and child link. So all of them are pretty much the same. So you add the front right leg, then you add the corresponding joint that connects the front right um, leg to the base link, which was the torso, basically. Now I'm going to show you something else right now. So this is how you create your robot. There's one other thing that I might show you in another video, and that's how you uh, basically how to bring a robot that's already built. You know, maybe you have a robot in Autodesk 360, or you have a robot inside Blender or one of these 3D softwares, and you want to bring it in. So you export those files inside, export those files as STL files, and then you bring those, instead of having a box or a sphere, you import the mesh file inside the URDF file. I might show that in another video. The other thing is, when you look at these files, so I've made this URDF file from scratch, but you also have a library. If I comment this out, you see in the next line, we have another. So you remember I loaded the R2D2 file, but right now we have another robot, which is a Lycago. Lycago is the famous Lycago file that was basically, as it looks like a dog. I'm going to see if I can load this up here so you can see. So you can see that this Lycago robot is here. The issue is that it's landing on its back. So you have to, when you do, when it happens, you have to, it looks like the start orientation is not correct. So I'm going to change this to 3.104 and see if it really affects it in any way positively. I'm going to stop the other one and load it. Now it's landing on its head instead of on its back. So again, not so accurate. I'm going to go back and I'm going to do one more try. Looks like we're supposed to change the orientation from the y-axis. Let's see. No, the same way. It's not landing on its four legs. My oh, maybe we need to do a, instead of doing the 3.14, we do a 3.14 divided by 2. My guess is that. I'll do another try, and if I don't figure it out, I'll let you figure it out. Okay, there you go. Now it's landing on its four legs, because I had to rotate it 90 degrees instead of 180. And because the front is heavy, it's kind of tilts forward, but And the problem is kind of solved for right now. Then we have to figure out how to change, change other parameters that it prevents it from tilting forward. So that was a kind of introduction to, how to load a robot inside URDF. Guys, this is very powerful stuff. Once you do this, so in the next video, I'm going to, you know, introduce a function that helps you move, at different links. And because once you learn that, you can, is a parameterized movement or parameterized motion of the links. Once you learn that, you can actually play with those parameters and start training the robot to walk or do whatever you want. So it's very powerful. And I will tell you, with this, you can do so many things. The sky is the limit. Very simple tool, open source, free, unbelievable what we have in our hands, and so many things you can do with it. You can 3D print it at the end, make it, make it do wonders. So stay tuned. I'll come back with another video in a few days.